Hello, I'm Sabrina Vander, a junior biomedical engineering student at the College of New Jersey. My research this summer took place in the biomechanics lab at the college under the guidance of Dr. Anthony Lau. My research focused on the bone microstructural changes in rat tibias exposed to space radiation. There is little research on how bone is affected by radiation on a micro scale. This knowledge is important to astronaut health, which is why I chose to study it. The lab itself has a large cohort of rats that have been exposed to radiation. However, due to delays, I was only able to focus on a smaller cohort of rats that have been exposed to 90 days of protracted radiation. Of these 12 rats, 6 are female and 6 were male. 4 females and 2 males underwent 5-ion galactic cosmic radiation at a dose of 50 centigrades. The other 4 male and 2 females were not exposed to any radiation as they served as a control group. Once the rats were irradiated, they were euthanized and their hind limbs were collected. Once the hind limbs were cleaned off, they were sent to ScanCo, where they were micro CT scanned at a resolution of 8 micrometers. Once we were able to get the DICOMs of the scans, we uploaded them to Mimics. In Mimics, we were able to rotate and reslice the scans to improve the accuracy of our calculations. 2 masks were created, one that consisted of just the cortical bone and the other consisting of just the trabecular bone. This was so we could do analysis on them separately. Once the masks were made, they were uploaded into ImageJ. In ImageJ, we used the plugin BoneJ to calculate the bone volume, bone thickness, and trabecular connectivity. We were also able to render 3D models of the bone thickness. Here you can see this is the cortical bone and trabecular bone 3D models. Both these come from the same female specimen exposed to the protracted radiation. Once the calculations were all made and the models were rendered, we did statistical analysis using a linear mixed model to evaluate differences for sex and treatment. We found that there was no statistical significant difference between the bone health of the bones exposed to radiation and the control group. However, we did find differences in the microarchitecture of the females and male bones. The bone volume of the cortical bone was found to be significantly decreased in the females compared to the males. However, the trabecular connectivity was found to be significantly increased in the females compared to the males. You can see this visually in these 3D models. This is a male and this is a female trabecular 3D model. Neither of these specimens were exposed to radiation. Due to the lack of specimen used in this study, conclusions were difficult to make. However, future work includes finishing analysis on the entire cohort, which should increase statistical power. Our future work also involves investigating the differences between acute and protracted radiation. Thank you.